Hello everyone, in this series we'll discuss about 8051 microcontroller and its assembly level programming. So let's get started. First let us understand what is a microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. As the definition says, a microcontroller is designed for a specific operation in an embedded system. For example, a voting machine. When you consider a voting machine, the microcontroller in a voting machine is designed in such a way that it carries out the entire operation of the voting machine. You might have seen many toys and other robots, toy robots and many other robots where the microcontroller is used to carry many operations. For example, path follower robots and many other toy robots. We understand what is microcontroller by knowing the difference between a microprocessor and a microcontroller. What is a microcontroller and what is a microprocessor? A microprocessor, let us see the block diagram of a microprocessor. A microprocessor is an integrated circuit that contains all the functions of a central processing unit of a computer. So as the definition says, the microprocessor is the one which contains all the functions of a CPU of a computer. So as you can see, the block diagram of a microprocessor, it has the following blocks. But in addition to that, the microcontroller has internal ROM on chip, RAM on chip, and IO ports and other circuitry. So as you can see the block diagram, this is the major difference and also the operation. A microprocessor is the one which acts as a complete CPU of a computer, but a microcontroller is designed for a specific operation or for a specific embedded system. As you can see the block diagram of a microcomputer, this block, what you can see here, actually represents a microprocessor. A microprocessor connected to along with the IO devices and the memory, that is ROM and RAM. It represents a microcomputer. So, I discussed earlier, this is the microcomputer. Now let us understand the block diagram of microprocessor. So firstly, the control unit. The control unit is the part of the CPU which provides synchronization, timing and control signals, and also it is the main unit which actually makes the microcontroller understand the instructions. And the ALU, which stands for Arithmetic Logic Unit, is responsible for the arithmetical and logical operations. So the ALU register A, which is also called as accumulator, in 8051 microcontroller, that is of 8-bit. Now that we are seeing the block diagram of a microprocessor, the ALU is responsible for the arithmetical operations such as addition, subtraction, division, and the logical operations like AND, OR, and all logical operations. As you can see, there is an interrupt circuit. What is the interrupt circuit? Now let us understand what is interruption. Interrupt circuit is the one which lets the microprocessor or a microcontroller understand that an event needs the service of the microcontroller or a microprocessor. For example, let's consider an example. Suppose you are studying or doing something and you'll get a call from your friend, and your friend will ask you for help. In this case, your friend can be seen as the interrupt circuit, and you can see yourself as a microcontroller, and the current operation as reading or writing. So you are doing the operation. You yourself as a microcontroller, you are performing the operation of studying, and your friend calls you up and asks you something. So your friend will be the interrupt circuit. So the help which your friend asks you will be the event. So interrupt circuit lets the microcontroller or a microprocessor understand that an event needs the service of the microcontroller. The clock and timing circuit is the one which decides the speed of the microprocessor to complete an operation and also the baud rate in serial communication, time taken for the conversions. As you can see, there's one more block called stack. What is a stack? As per the definition, stack is that part of the memory which is set aside by the user to store subprograms and subroutines. So what is a subprogram and subroutine? So stack is that part of the memory which is used to store subprogram and subroutines, or used to execute subprogram and subroutines. But what is a subprogram? If you know anything about C program, just like how you program functions, here in assembly level program, there is something called subprogram and subroutines. So suppose you're programming your day, and there are many functions that you do. If you're programming your day, and the first task would be waking up, the second task would be taking shower, and the third task would be having breakfast. So if you have to program Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, instead of writing the same code for each program, for example, instead of writing 10 lines of code for writing the code for the function or to carry out the operation of having breakfast, and instead of writing so many lines of code for the function to carry out the operation of taking shower, what you can actually do is you can write all these programs separately and call them in your main function. Just like functions of C program, you can call these subprograms and subroutines in the main program. So these are called as subprograms and subroutines. And stack is that part of the memory set aside by the user which actually is responsible for execution of these subprograms and subroutines. And here in this block diagram, there is something called as a program counter. But in case of a microprocessor, it is usually called as instruction pointer. So let's not discuss much about the microprocessor, because here in this series we learn more about microcontroller. In microcontroller, as you can see the block diagram of a microcontroller along with the options that were provided in the microprocessor, you have additional features such as I/O ports and memory and other circuitry. Now, as you can see, there is a stack pointer. Here in case of 8051 microcontroller, The stack pointer is of 8 bits. We'll discuss the stack about the stack pointer. Now let us see what is a program counter. Now what is a program counter? Program counter is a 16-bit register in case of 8051 microcontroller. Suppose your program is being executed and this particular instruction is being executed. The function of program counter is to point the address of the next location For example, if the instruction from the address 1323H is being executed currently, the program counter will be pointing towards the next location so that it can fetch it from that particular location. So we'll learn about program counter in depth in further classes. This is just a basic knowledge of program counter. Now let us understand what is stack pointer. Now stack pointer, as discussed, is a 8-bit register. So now that is a 8-bit register, let us see how many memory location it can access. So 2 power 8 would be 266. Sorry, 256. 2 power 8 is always 256. So it can access up to 256 memory locations. So that is how we calculate it. So 256 will be from 00H to FFH in hexadecimal. That is basically 00, 01, 02, 03 to FFH, which is nothing but in decimal it will be 0 to 255. We'll study about stack and stack pointer in detail in further sessions. Here I'm just trying to provide you some basic idea. Now suppose you want, let's compare this to a bookshelf. Let's think that you want to put, now let's assume that you want to store books on a bookshelf and we are comparing the stack to a bookshelf. Now let's assume the book's name is B1 and you are keeping the book in the in this particular shelf, and each shelf is having a address location. So this book is kept in this particular shelf and the name or address location of that particular shelf is 07H. Now suppose you want to place another book. So what's going to happen here is it's going to get incremented by 1. So stack pointer gets incremented by 1. So it is currently pointing at 07H. SP plus 1, that is stack pointer, will get incremented 1 by 1. So that will point to 08H. And your new book, book 2, can be stored here. This is just a basic idea. We'll study about stack and stack pointer in depth in further classes. And it has timer and counter. If the microcontroller counts external events happening outside the microcontroller, then it can be used as a counter. The particular circuit can be used as a counter. If that is used to generate internal time delays, then that can be used as a timer. And as you can see, there is a RAM and ROM. The ROM is used to